So imagine you're building a voice agent for a room, meeting room where there are active, multiple speakers active, and but only one of those speakers is talking to the agent. The other are talking among themselves. They are having a conversation which is not relevant to the agent. Okay, so what you would want the agent to do is to narrow down and focus on the particular speaker who's, who's who's actually talking to the agent and ignore the conversation, sort of an attention mechanism that narrows down the speaker. So this is what humans naturally do. But what happens right now, the speech to text system, it takes in all the on inputs and interleaves the conversation among both the actual the important conversation and the background distracting conversation. So whereas we want only the active talker to be heard, you only want the agent to hear only the active talker. So this is not natural to humans. Humans have a natural ability to focus on the person who's active, their active speaker at a point, and ignore the conversation, even though they do hear it, the rest of the conversation. Attention Labs did a very created a very nice toolbox, hardware-based system that actually does selective hearing. And so they bring this for the first time to automated agent. And how it works is that they call it selective auditory attention. Okay, so SAA takes as input the the audio waveform from coming from different places and outputs what the output active talker is. Um, so it isolates the speaker who's active. And how it does that is the SAA module actually looks for linguistic cues in the audio it's hearing, head pose shifts, and turn taking. So these are three different modalities that it takes. It perceives and outputs a 3D map of who's speaking where. Okay, so it creates a 3D map of who's speaking where, and by building that, it is able to figure out who's the active speaker and who it should pay attention to. It's both semantic and distance based. Uh, it takes care of the turn taking as well as linguistic cues that bring the semantic and head pose shifts and the distance that all of these features together let it figure out who the active speaker is. The output here is the speaker with the confidence value. So in the beginning speaker S1 is the central speaker, is the active speaker, and the output chunks are annotated by that. At some point there's a shift event, and now the speaker S2 becomes the active one, and you hear the text, hear what agent hears only the S2. So this is really remarkable. It allows the agent to focus on what is actually meant for it without any wake word or any prompting word. Can automatically move its attention to where the relevant speech is. And the solution is hardware based, so it's very little power consumption, 10 second, tens of watts, and latency is also pretty low. Latency is very important for voice pipelines. So this is 100 millisecond, and privacy is guaranteed because it's done in hardware before the stream goes out of the hardware. Integration is pretty easy. Uh, all you need to do is to one API call instantiates the engine and begins emitting per speaker audio frames with confidence scores and focus shift events. Multiple languages are supported. So this is a great work, I think, which brings the missing element, which is the active speaker detection and active speaker isolation. Uh, so, so you can, one of the deepest problems with the agents right now is that even though they have um, noise detection, for example, through crisp libraries and turn detection, semantic turn detection, the ability to isolate the active speaker or get rid of all the distracting conversations in a crowded room. That's the thing that's not available, and I believe that this feature will be essential and will be incorporated almost all of the agents going forward.